All right. So when I first looked at the web page for PHPKonf, I didn't see any clickbaity enough titles, so I figured I should make one. And initially, it was less clickbaity because it was 3 things you probably never heard, or maybe you did, but not that many times. But I figured the first part is more clickbaity, and every conf should have one. My name is Bilgem, and I am really not in my element here. I'm not a PHP person at all. Part of me is still surprised that I'm even invited here. But I'm a grumpy old graphics vision game dev. I started back in the late 80s on Commodore 64s. I was part of the European demo scene, which some of you may not be even familiar with what that is. It's like a computer subculture of people who make hard-to-code graphic effects synchronized with like music and art kind of thing. Then that led into consumer devices and games. And eventually, I went over the pond to work at the Empire. I worked for Windows DirectX team for about 6 years. And then worked on Amazon on some crazy projects. I was part of the 3D Fire phone thing. Then I built the cashierless store Amazon Go thing most recently. And now, like very recently, about 4 months ago, I left and started my own thing. And one other thing that happened during that last 4 months is I started a YouTube channel, which I think is why I'm here, that got somewhat popular. So thanks for having me, I guess. Now, I'll start with like 2 little stories that I thought was really funny. Probably a lot of people here would not recognize the scene. This is a scene from an old movie, an old Turkish movie from like 1989, I believe. It's called Don't Let Him Shoot the Kite. It's a drama that takes place in a prison, in a women's prison. But this particular scene is funny. This guy here is like this like officer, senior officer in the prison, and they're facing the inmates. And these 3 guys are his subordinates, and they find this envelope, this letter. So he decides this is too dangerous. This envelope must be destroyed for whatever reason. So he calls on this first guy, and he says, take this envelope and go and burn it. And then that guy walks away. The second guy, he calls the second guy. He's like, go follow that dude and make sure he destroys the envelope. And then that guy goes, and then he calls the third guy. And he's like, go and follow that second dude and make sure that he makes sure the first guy actually burns the envelope. And then they come back a few minutes later. First, the third guy comes back. He's like, I made sure. The second guy made sure, you know. And then the second guy comes back, I made sure. And the third guy, I just burned the envelope. It was just a nice scene that kind of depicts the issues with bureaucracy and trust. And then the second one is a schematic of my great drawing skills of depicting a pen shop in South Africa. So in this shop, you can go. The customer can go to the first station where there's this person who shows you the pens. So you go and you pick what pen you like, and you're like, okay, I want that pen. And that person gives you a little paper. You take that paper, you go to the second station, and that person takes your money. You pay them. And that person then in return puts a stamp on that paper, and you take that paper to the third station, and that person gives you your pen. So, of course, there are reasons why this thing is designed this way, which we'll talk about later. But let's park these 2 stories to the side. Now, before I start with the 3 things that you never probably heard, or maybe you did, but not that many times, some warnings. The tone of the presentation may be a little stronger than it really is logical. It's not because I feel that strongly about it. It's not like that I'm an opinionated prick or something. But it's really because I really feel sometimes we are always around our own circles, and we keep hearing the same things over and over again. And our expectation of our perspective about the range of possibilities, the range of approaches that make sense to a particular problem, gets smaller and smaller and smaller over time. And I think opinionated language kind of pushes that. Like, you may hear someone talking, passionately about something, and you may totally disagree with them, but still that has a benefit of, there's a benefit of hearing that. So that's why the language is a little maybe harder. Now, the three things. Thing one, premature optimization is bad-ish. It's not the root of all evil, please, but it's okay. It's not great, but I really think premature reusability is worse. So before I talk about what's bad about reusability, I'll say a few things about why optimization isn't that bad. Actually, Rasmus really said enough about it, I think, in the keynote. But when I say optimization, first of all, I'm not talking about like elaborate data structures to optimize access, and I'm not talking about OC trees for visibility, KD trees for this. I'm really talking about simplicity and size, which, again, from what I learned in the morning session, is what kind of happened with PHP 7, right? So I'm talking about the type of optimizations we can achieve by paying attention to size of things and limiting the amount of data we process. And it's really, really, really about memory access patterns. Like this will continue for a long while with the current architectures that we have, that the gap between CPU speed and memory speed will continue to increase. Therefore, caching will continue to be more and more important. Therefore, how we access memory and how much memory we access is going to continue to make impacts of this order, that like 10x. It's very possible to go find software out there in the wild and make it 10x, 100x, or 1,000x more efficient, faster, without really increasing the complexity of the code. So the only reason why this is not happening today, I believe, is because our bias for what the performance should be for any given thing has deteriorated so much over the last 2-3 decades that we seem to care much less about this. But I really think this does, performance today in the world of mobile devices is equal to battery and power consumption. So you're like, if you don't make things fast, you're burning battery. Likewise, in the big server rooms, like again Rasmus mentioned, like we are pumping carbon dioxide because our software is bad. But really, what I want to talk about here is some issues with reuse. We are so used to, like as we come out of our colleges, reusability is great, and we love it. We learn a zillion different tricks to increase the reusability of the software that we create. And one of the ways we achieve it is by using abstractions. And I'm going to lay out a chain of causality here about why I believe reusability is bad. Reuse requires abstraction. Abstraction introduces contracts. It's most often we may abstract away a certain chunk of code to here and put it behind an interface. The moment we put an interface there, we really are introducing a contract to a system, a contract about what should be passed to that interface, what can be passed, when this interface can be called, what the state of the thing that we are calling should be when we are calling it. And all these things are, and what it can return back to us, etc. All these things are defined by a contract. We may explicitly define a contract and be intentional about it, or we may not be intentional about it, and then we find the contract over time by bugs coming out. But these contracts require verification, local verification within the code that's hidden behind the interface, if we want to make them really reusable. If we don't make these verifications inside that code, and instead we do them in the caller's scope, then it's likely that when we take that code and try to call it from elsewhere, that place may not check the same contract, therefore we may introduce bugs. And contracts also require communications overhead, because before we took out that chunk of code from where it was, it used to have access to a bunch of things there. Maybe it was a private method inside a class that was accessing the members. Maybe it was a chunk, like 10 lines of code within another function that was accessing the local variables. Either way, there's some chunk of data that was accessible, that was in the scope, and then now we are moving this thing away. Therefore, we need to solve the problem how we pass that information to the other side. That's what I mean by the communications overhead. And another kind of obvious observation is that reusability usually tends to increase with granularity. The smaller we make things, and the smaller we make those interfaces and chunks, the more reusable they're likely to become. Like, we are slowly converging towards this thing where it does really one thing. It has one clearly defined responsibility, et cetera, which is great, and it makes it reusable. But what that also means is these local verification overhead and communications overhead compared to the business logic of that chunk of code, that ratio now deteriorates in a way that overhead tends to increase with the granularity. So after all these things, we end up in this situation. So this is a Java call stack. I took this from, I first saw this from a Jonathan Blow talk. Jonathan Blow is a kind of really good indie dev, famous for Braid and Witness. And he took it in turn from somebody's blog called Peter Thomas. And there, that guy actually isn't even complaining about this. He's like, hey, guys, I actually studied the call stack of what happens, and I actually divided to, into the libraries of what's happening. This actually goes down further down here. I just didn't have, I couldn't capture it. It didn't fit my screen. Something is wrong with this picture, I think. Like, I'm really trying hard not to just say this is insane. Like, I mean, there's probably some context somewhere, some set of conditions that led to this, but this is also a part of reuse. And the number 2 problem is, this is, I think, kind of sad, because I spent quite a lot of time working on middlewares, and one of the big problems is to make any middleware useful, let's say a graphics library, to make it reusable, to make it useful to many, many, many people, we try to make it support as many scenarios as possible. So for the same graphic library, we may want to have office applications people be able to do their thing with that. We may want to have games people do their thing with that. Those games can, if we could be making a game engine that somebody is trying to use to make a car racing game. Somebody else may be trying to make an RPG game. These things have insanely giant differences in their context. Yet, as the middleware developer there, I'm working on this game engine or graphics engine, and I know nothing about, I can't make any assumptions because of all these scenarios. And to achieve this, I have to now design my library. The code I design inside the library has to have lots of dynamic management, including dynamic memory management, because I don't know the size of things ahead of the time. I can't put limits. I can't assume anything. And that leads to bad perf, because for the simplest case, if I'm using a lot of dynamic allocation, my memory is scattered everywhere. Now cache performance suffers from that. The other thing is, again, to kind of make this useful to a lot of people, I designed my API contracts to be as allowing as possible. We used to call this policy in Microsoft. And Microsoft had this design tenet within the teams where any team that's kind of lower in the software stack, in the performance critical levels, we would like to have, the lower you go, the less policy you should have. Because policy means magic, right? I mean, you put something there and you make a call over here, and on the middleware side, we're like, we're not quite sure what you're doing, but you probably meant this, so I'm going to assume that this is what your intention is, therefore I'm going to do that. Like that kind of deducing what the user is trying to achieve is what I mean by policy. And the worst part of this is when you sit down to optimize a chunk of code, the number one set of useful tools we typically have is knowing the input and the output and like what the system is doing in this particular context. I may know that there's, like maybe I have a pathfinding algorithm that does something, but if I know the level and what properties it has, or all the levels in my game, and make some rules there, and I know this never, the size of this data never goes past this, or the number of number of neighbors of a given cell is never beyond this, etc. The moment I know those things, I can simplify a lot of code, and that can in turn give me a lot of perf. Again, all of that set of tools for optimization, as a middleware developer, I can't touch because I can't make any of those assumptions. As a result, now any user who's trying to use my graphic library has this big library under them, and they're actually not even using most of the features that I built in there. Like I mean, this is a simplification, but like the car racing game guy isn't using a lot of the features I built for the RPG guy, right? And yet they pay for it. They're paying it for their runtime memory. They're paying it in the form of the dynamicism, the dynamic choices I made in the design. So because this is kind of a controversial thing, I figured I should put someone more credible than me. And that's, this is from the refactoring book from Fowler and Beck and all these guys. And by the way, there are things that I very strongly disagree with the extreme programming people, etc. But this is even something that we agree on. Reuse is often touted as the purpose of objects. We think reuse is overrated. So one problem with this is reusability is very tough to measure objectively. You will spend your entire careers finding yourselves in meetings where you're discussing with people about whether you should choose option A or option B for the particular design, and the guy next to you will say, but if you choose option A, it's going to be more reusable. And you really can't measure that. It's not like option A's reusability score is 7 and option B's reusability score is 6.4. It's tough to say that. And it's not a good idea to get religious on matters that are not measurable. So, this is something that I feel like I'm going into dangerous waters here with this audience. But, microservices are a popular thing. But I think there's parallels with this and this. So at least in my, and again, I may be missing a lot of context here, but it's also a common, kind of a naughty tradition among game devs to make fun of Twitter. Because, we usually say Twitter was the same site in 2010 and they had 15 people, and now there are like 3,000 people and it's basically the same site. Therefore, where's all this manpower going? So I couldn't resist. But the real point, at least I can say this. I have seen microservices architectures where you would have these large number of services, each of which is doing a small thing, and then you start looking into the CPU loads in the servers for each service, and you see that like 70% of what a server is doing, what they're doing on their CPU load, is serialization, which is, they keep serializing data from a message into this like memory set of objects, and then they do like a small computation here and there, and then they kind of pack together again to their serialized thing, and then send it as requests to the other guys, across the system. If you have 1,000 services and then all of them are spending 70% of their time in serialization, that's a problem. In fact, like you can, I couldn't find, unfortunately, the image where I zoomed into this. I actually did look into this, and like one of the thickest, like that corner over there, if I remember correctly, was a service that's called something like message router or something, which again, is a yellow flag to me. But again, take that with a grain of salt. So I think what I'm really trying to point out is we don't have to go rail to rail. You know, there is a good reason people talk about microservices and etc. Like we don't want things to be monolithic. The anti-monolithic argument was the thing we used to discuss about objects and components and all that stuff, even before services, web services existed. Therefore, that does make sense. There is a point there. But like our two options aren't, you know, monolithic here and 1,000 microservices over there. Maybe there's, you know, middle ground. Maybe 10 of those services can be combined to one thing, and maybe that saves some things, you know. And those trade-offs are, I think, what engineering is about. So thing two, testing is good. Needing less tests is better. And both are better than on-call. How can you make your code need less tests? So the quality of software is obviously important, and there's an ethical side to this. Like it's an ethical responsibility as software engineers for us to try to create the code, the best code, the highest quality code, the most bug-free code we can. But because of the costs of developing tests, as an industry, we have been kind of moving away from testing. But at least I'm trying to conciliate here by trying to understand if there's something else we can do. To be able to answer that question, we need to think about what drives the test costs. What makes the number of tests you need go up? And usually it's complexity and corner cases. The more complex a code is, the easier it is for corner cases to hide in the corners of your code. And that also relates to branching. And the more branching you observe in a code flow, the more likely there are corner cases there. And there are metrics to measure things like that, like CCI. And another interesting point here is that the internal state plays a bad role in terms of complexity in the testing point of view, because now you have an interface that you're trying to test, but now it can have internal state that can be in different states, which ends up being a multiplier to the number of tests you would need like you would be interested in covering all combinations possibly. And things get one more level of multiplication from a set of arbitrary objects. So you can have an object here, an object there, an object there that has relationships between each other, that calls, you know, that makes requests from each other. Each of them have internal states. Now, from a formal perspective, completeness perspective, we are talking about trying to cover all the interfaces with all their internal state combinations, plus the combinations of all three objects in various combinations of states. One thing that we kind of do on the game coding land is we try to battle with this with more pipeline-like architectures. What I mean by pipeline is, the functional programming thing, which I know you guys are familiar with. There's an element of that, but there's also what we call a data-oriented approaches. So if you're not familiar with what data-oriented is, it's kind of a paradigm that positions itself as an alternative to object-oriented programming, which there's a really nice CPPKonf talk from 2014 by Mike Acton. I strongly recommend taking a look at that. But the pipelines gives us, if you design your system as a function that takes in some input, and makes some operations on it and puts it to the next stage. And then the next stage in the pipeline takes that, makes operations on it, puts it here. The next stage takes that. This kind of resembles a pipeline. The cool thing about this is pipelines are easier to test than arbitrary objects with relationships between them because they don't have state. Like each of those pipeline stages do not have internal state that multiplies things, which also gets rid of the multi-object state multiplier effect. And of course, concurrency is a difficulty that you may not be able to avoid. Like in games, for example, we can't not use the this additional CPU cores there. That would be crazy. But depending on the domain you're working on, concurrency is something to be wary of. So before I finish thing two, I need to kind of take this opportunity to rant about on-call. I hate on-call with all my being. And I really strongly feel every dev, every software developer should hate on-call and really push back against what many companies call on-call. Like, we need to really work on the definition of what on-call is and what it should be. It's becoming a norm now, unfortunately, in the industry, that the companies expect you to come there and start writing software and services and stuff, and then they expect you to be perfectly okay to be woken up at 2 a.m. in the morning with a pager so that you can go and SSH into a machine and restart a service. Devs are not IT personnel. This is not about, I'm not trying to talk down IT personnel, but the skills we get and the career, the investment we make into our careers is not about restarting services. The really right way to do this, I think, is to organize our organizations in a structure where there's levels of triage. And also on the dev side, we should be doing our best to produce systems that these other earlier levels of triage before us can work with, such that things are instrumented enough, they log well enough, whatever, and when something goes down in the middle of the night, there are other levels of people. It should be like what doctors go through with their triage process. So with that, thing number 3. So general software engineering know-how is important. But depending on the domain expertise may be more important. And I need to precisely define what I mean by domain versus general software engineering. What I mean by domain is the actual problem you're trying to solve. If you're building we were talking about this earlier today, if you're building a plane ticket buying kind of website, what happens between the agencies and the airlines and the planes, how the tickets actually go from one place to other, all that stuff is your domain. That's the problem you're trying to solve. If I'm making a game, the animation or the rendering or the particular game genre, what simulation I'm trying to do is the problem domain. If you're doing the manager, the classic object-oriented examples like manager, employee, blah, blah, that thing, if you're doing that is your domain. And that domain can be shallow or it can be deep, depending on different things. You may be working on computer vision or machine learning, and there's you can spend your entire life on trying to learn and become a domain expert on machine learning, and there would still be many things to learn. But there may be other domains where that's not the case. And what I mean by general software engineering is this domain-independent design know-how that we acquire through, we have ideas about what the right design patterns are, or what object-oriented design should be like, how we should reduce coupling between classes, all that stuff. Plus, all the process know-how. We spent years discussing the waterfall versus the IBM's rational tool suite versus the Scrum and Agile and all that stuff. So all of that is good knowledge, what to do when a bug comes in, what should be the life cycle of an issue that is filed into a system, is it 5 states, 4 states? All of that stuff is important, and that's what I mean by software engineering. This is stuff that is domain independent. You can apply this to many different places. So any project we find ourselves in have both of these components, like the problems we need to solve to successfully complete a project. Part of them will come from one side, part of them will come from the other. For deep domains, I claim here that the highest risks, the biggest risks of us getting something wrong, lay in the areas of domain. And those risks dominate any risks we may have from getting the object design wrong or getting an interface not, or too coupled or something. As an example, again, not surprisingly, I'm going to talk about games where the graphics, fairly or unfairly, the graphics of how a game looks, how well it looks and feels, is like a big factor in how well the game does financially. And in this world, the frame per second and the quality of the graphics are the highest priority. In the industry for a long time now, recently the functional programming thing has made way and elsewhere. But for a long time, we kind of pretty much immediately assumed like when we were about to start a project, we would assume object-oriented design was the right way to go. And this was very common. At some point, like late aughts, which means like somewhere between 2005 and 2010, gaming people started to really feel object-oriented programming was not helping them. It was creating some new problems that we didn't need to solve, and it wasn't helping us solve some of the hardest problems. And by now, actually, today, it's pretty universally accepted that object-oriented is not good for games. And because, like I said, the highest risks are not there. You're trying to simulate a world and do all the animations, crazy stuff, and do a chunk of rendering all within 16 milliseconds. What you get wrong there with something you get wrong with how you model the simulation data and how it relates to the rendering, you can't refactor your way out of that. And that's much more important compared to if your such and such class is a bit too coupled to this other class over here. Or which design pattern fits where. Or whether we use Scrum or Kanban or Waterfall. So again, so before I say this, this is particularly this terminology I'm referring to here, the domain expert versus the software engineer, kind of mirrors these early 2000s point of view where you would find these, this is kind of echoed in the extreme programming books as well. You would find these books on software engineering where they would be written by these people who are consultants who go to a project and they kind of work with the people there, and they would have this character called the domain expert in the table with them, and they would claim that the domain expert should be a stakeholder, and we work together and we understand, and then we make the software. What I'm here claiming is that, no, this domain expert guy is not some other guy. You should be equally expert about the domain you're building software for. Otherwise, it's you run into this, like a game developer who comes from kind of a more formal software engineering approach without any domain expertise would have a very difficult time shipping games. And this actually, I just said this already, but one of my favorite kind of architecture guys, James Coplien, says something about this, and he uses as an example a banking software. I don't remember the details of this, but he was talking about how banking software is like a transaction system or something. And if you came to it from a kind of naive, okay, I'm going to find my names and turn them into objects and find the relationships. I'm going to have an account object, and then I'm going to derive a, like checking account and a savings account, like that kind of approach. He was saying that actually doesn't represent how accounting really works in banks. Therefore, you could not actually refactor your way out of this. You would be way too deep into trouble before you realize your mistake. So really, there's a main theme between these three things that I was trying to communicate here, which is a theme about simplicity versus complexity. Unfortunately, simplicity is exactly like reusability is very tough to objectively measure. Even though we try to come up with things like CCI, we try to come up with metrics, it's kind of subjective. But at least the awareness about how complexity creeps into a system is important. Even though how simple or complex something is debatable, we usually, when we componentize things or abstract things away, we make those decisions to favor simplifying things. Nobody's stupid. Everybody's trying to achieve the same kind of simplification on their job. But I guess what I'm trying to say is we also should equally pay attention to how much complexity we are introducing to the global system in return for this little simplification we do at a local scope. So my personal way about thinking about this issue is reducing bureaucracy. So this is bureaucracy, and this thing here, these two examples, one is a comical one. The other is, like the one on the right, is more familiar. We have seen systems like this. Why does this happen? It's not smart to just rant about bureaucracy and say that it's a bad thing. There is usefulness to bureaucracy at times. We need to understand why bureaucracy exists in the first place. It exists because of trust issues. What's happening here is the people who designed the store does not trust this customer enough to let them have a pen and the money in their hands simultaneously. This entire design here is made to avoid that. But more interestingly, I think they also don't trust these three employees. None of the three also has those two things at the same time, and that's their problem. So maybe for some cases that makes sense. Maybe for a pen-selling shop, it does not. Maybe there's a way to cope with this. Maybe there should be really one station with many guys behind it waiting for you, and you pick your pen and pay the money and take the pen and leave. I don't know. But we need to pay attention. And this guy is even funnier because given the time frame and the environment in Turkey, I'm pretty sure this guy smokes. So this guy actually probably very likely has a lighter in his pocket, and he could just pull and burn the thing. But instead of that, he tries to make that, the one thing, this is not my responsibility, it's his responsibility. He creates a problem for himself because now he doesn't trust this guy. And this is a chain. Like, this happens so much in real software systems that we make choices that create additional complexities for us that we try to build additional systems to solve. So, but again, it's critical to understand in our domain, in our case, why is this happening? And we need to understand, we need to be intentional. That really needs to be our goal, to add that trust system for the domain reasons. So I guess the question I want to leave everyone with is your code beginning to look like an organization with lots of unnecessary bureaucracy? Premature reusability adds bad bureaucracy and clogs the data flow because now there's all these checks and verifications and all that. And you can do things to streamline that data flow, which in turn will help reduce your tests that you need. And to be able to do any of these things, you really need to have the domain expertise. You really need to understand the actual problem you're trying to solve. That's the only way we can achieve these types of simplifications and the correct judgment of which part of which bureaucracy is really needed and helps us from a domain perspective. Thank you very much.